What's up guys, my name is Donnie and today we are studying further and deeper about permutations. In permutation, there are repeated permutation with repeated values, careful, this sounds the same but they actually aren't, and circular permutation. Let's start with repeated permutation. Let's say we have a set of cards. Here we have 1, 2, 3, and 4. How many numbers of 3 digits can you make with the cards? As we studied previously, by using the permutations, we get 4 factorial. Out of 4 cards, we choose 3 cards, which becomes 4 factorial divided by 4 minus 3 factorial, which becomes 4 factorial divided by 1 factorial equals 4 factorial equals 24. But what if the question says, you may use the cards repeatedly? In that case, we get 4 times 4 times 4, which equals 64. In this first card, we can use all the 4 cards. That works same for the second as well, and for the third digit as well. In that case, we get 4 times 4 times 4, which equals 64. This is repeated permutation. Unlike the permutation we've seen before, where value cannot be used again, repeated permutation counts the orders where the values are used more than once. We write this into an equation 2 n pi r, where n is the different values of x and r is the number of x being chosen. Out of 4 different cards, we choose 3 times, so we have 4 powered by 3 equals 64. N pi r, if you change it to an equation, becomes n powered by r. This is repeated permutation. Now let's move on to permutation with repeated values. Gosh, the names are so similar. Let's say we have 3 yellow balls and 4 blue balls. What is the number of possible events aligning the balls? Counting one by one would be confusing because either the first yellow ball being in the front and the second yellow ball being in the second, and let's say there's 1, 2, and second yellow ball being in the front and first yellow ball being in the front would be the same. We use the following equation to cure our headache. The equation is n factorial divided by p factorial multiplied by q factorial. N is the total number of values. So n in this question would be 7 because there's total 7 values. 7 factorial divided by Q, P, and Q are each of the repeated values, the number of the repeated values. So we have 3 yellow balls here, so we have 3 factorial multiplied by, we have 4 blue balls here, which is 4 factorial. It's not only P and Q you could have, there could be P, Q, R, if there's more repeated values. Let's take another example. This time, let's say there's also 5 red balls that are joining the line. 5 red balls with 4 pink balls as well. So now we have 3 yellow balls, 4 blue balls, and then 5 red balls and 4 pink balls. What would be the total number of possible values? It would be, how many values do we have in total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, and then 16. So it will be 16 factorial divided by, for pink we have 4 factorial multiplied by 5 factorial multiplied by, we have 3 yellow balls and 4 blue balls, 4 factorial multiplied by, 3 factorial multiplied by 4 factorial. This is the permutation with repeated values. The last stage for today is the circular permutation. Let's say a family is trying to sit on a table. Father, mother, a daughter, son, and a puppy. What will be the total number of possible events the family sitting on a table? Well, let's use the ordinary permutation we learned previously and calculate it. Out of 5 members of the family, we're going to choose 5 to sit on a table, which would become 5 factorial over 5 minus 5 factorial, which is going to be 5 factorial over 0 factorial, which equals 5 factorial. But this wouldn't be happening. So now, is the problem solved? Well, let's think like this. Let's say a mother was sitting here, father, son, daughter, and a puppy. Wouldn't mother sitting here, father sitting here, son sitting here, daughter sitting here, puppy sitting here be the same as the previous one? It may look different, but the thing is, father is right side of mother, puppy is left side of mother, a daughter is right between puppy and son, which is happening the same in the both situation. And this is going to be happening 5 more times whenever mother is sitting on top or next, here, 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 or here. So what happens in a circular function is that you do n factorial as we did before, but you gotta divide this by n because it's gonna happen the nth number of time. So here we had 5 factorial, which is about to happen, and there's 5 family members. We have to divide by 5 because it's gonna happen 5 more times where mother sits at the top, right bottom, or left top. And this is gonna happen to everyone, whether father sits here, 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 or here. That is the circular function. Let's take another example. Let's say that student A, B, C, and D are to sit on the table. They're going to sit this side, this side, this side, and this side. What will be the total number of possible events in this situation? So now we have 4 students, so it's going to be 4 factorial over 4. Because either student A sits here, or here, and here, and here, the value is going to be still the same. A, B, C, C, and D, whether it's like that, or whether if it's like D, A, C, D, A, B, and C. They just moved one to the right side. And this is still the same as the previous one. That's why it becomes 4 factorial divided by 4. The equation, just to remind you guys again, is n factorial over n. This is the circular function, circular permutation. The final stage of today's video. There are 3 questions that are prepared. I hope you guys solve it, pause the video, and solve it yourselves, and then follow me with the solutions. Alright, I reckon that you guys already have solved the problems, so I'll start writing the solutions here. So you're forming a 3-digit code with the following letters A, B, C, D, E, and F. That's total 6 values. By using the equation we have learned in the front, out of 6 values, we are choosing 3. And this becomes 6/3, which becomes 216. That is the answer. Remember that n pi r equals n powered by r. Second, here. Tom is trying to reorganize the word prepare. How many different results can there be? By reorganize, it means changing the orders of the alphabets. Example, P, P, R, R, E, E, A. So this is a permutation with repeated values. Here we have 2 of P, we have 2 of R, 2 of E, and we have 1 A. So how many values are there in total? It's 7. So 7 factorial divided by 2 factorial multiplied by 2 factorial multiplied by 1 factorial equals 7 factorial divided by 4. That is the answer. Last question. 6 kids are sitting on a round table. So there's a round table. There's a kid here, 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 and here. What is the total number of possible events of kids sitting on the table? So 6 kids are sitting on the table, 6 factorial, and there's going to be 6 similar values, but because if you just change the order of the kids to the right one side, that's still the same. Another to the one side, that's always the same. So 6 factorial divided by 6 repeated same value equals same as 5 factorial, which is 120. That's it for today. Thank you guys for listening to my video. I hope you guys really liked it. Like it, comment it, and then send me questions if you have any inquiries.